Imagine a traveler from a distant neighborhood arriving at your doorstep with stories to tell. That is exactly what happened this summer, when Comet 3I Atlas came calling from beyond our solar system. Scientists, quietly and with great care, have been working tirelessly to learn everything they can about this rare, cosmic visitor. Their discoveries are, already, rewriting our understanding of how planets and comets form around distant stars. The most exciting finding? This interstellar wanderer is releasing water vapor into space, offering us a precious glimpse into the chemistry of another star system. First detection. Scientists detected hydroxyl gas, OH, from an interstellar object, for the first time, providing strong evidence of water activity. Each interstellar visitor has been different, and this comet is actively releasing water far from the Sun. NASA's Swift Observatory captured ultraviolet signals that Earth-based telescopes simply cannot see. The comet releases water at an unusual distance, by a process scientists are still working to understand. The discovery confirms that the basic building blocks of life exist beyond our solar system. What makes 3I Atlas special? Comet 3I Atlas holds a rare distinction. It is the third confirmed visitor to arrive at our solar system from interstellar space. Think of it as receiving a message in a bottle from across an ocean, except this ocean is the vast emptiness between star systems, and the message tells us about worlds we cannot yet visit. The Atlas survey, in Chile, first spotted this celestial traveler on July 1, 2025. Scientists quickly realized it was not from our neighborhood. How did they know? The comet follows a hyperbolic trajectory. In simple terms, an open-ended path through space. Unlike comets born in our solar system, which orbit the Sun in closed loops, 3I Atlas is simply passing through, never to return. A brief history of interstellar visitors. To appreciate Atlas, we must remember the visitors that came before. The first interstellar object, detected in 2017, was Oumuamua, curious and puzzling, and apparently dry, with no clear signs of water or outgassing. The second, in 2019, was 2I Borisov, more like a classic comet, but rich in carbon monoxide, suggesting it formed in an especially cold place. Now, 3I Atlas has added another chapter, by actively releasing water vapor, at distances where we did not expect such activity. As Zexi Xing, the Auburn University researcher who led the study, explained, "Every interstellar comet so far has been a surprise. Oumuamua was dry. Borisov was rich in carbon monoxide. And now, Atlas is giving up water, at a distance where we did not expect it." Each one is rewriting what we thought we knew about how planets and comets form around stars. The breakthrough discovery. Finding water's fingerprint. On September 30th, scientists published their findings in the Astrophysical Journal Letters. The Auburn University team had detected hydroxyl gas, OH, emanating from 3I Atlas, the first time this chemical fingerprint has been observed from an interstellar object. Why is hydroxyl so important? Because hydroxyl is the telltale fingerprint of water. When sunlight strikes water molecules in space, it breaks them apart, creating hydroxyl as a byproduct. Finding hydroxyl is like finding footprints in the snow. It tells you someone, or something containing water, has been there. Water, in comets, is the measuring stick scientists use to study activity. By detecting water signatures from 3I Atlas, astronomers can now compare this alien comet directly to comets born in our own solar system. This helps us understand whether the processes that formed comets around our Sun are similar to those around other stars. What are comets, anyway? Let us pause and picture the object. Comets are, in essence, giant orbs of frozen gases, rock, and dust, cosmic snowballs, preserved in deep freeze for billions of years. They contain pristine material, left over from when their star system was forming. As a comet approaches a star, the heat causes its solid nucleus to release gas and dust, a process called outgassing. This creates a glowing cloud, called a coma, that surrounds the nucleus, and often, a magnificent tail that can stretch for millions of miles. The coma and the tail are not the comet itself. They are material being shed as the frozen nucleus warms. Why this detection was so difficult? Detecting water from 3I Atlas required overcoming a major challenge. Scientists could not see the water directly. Instead, they looked for hydroxyl, which emits a faint glow in ultraviolet light. Here is the problem. Earth's atmosphere blocks almost all ultraviolet light from reaching the ground. No matter how powerful, ground-based telescopes cannot detect this crucial wavelength. NASA's Swift Observatory to the rescue. Enter NASA's Neil Gehrels Swift Observatory. Swift is a space-based telescope, orbiting high above Earth's atmosphere, with a clear, unobstructed view of the cosmos in ultraviolet light. Think of it as a window that can see colors invisible to the human eye. Swift's ultraviolet instruments captured the faint signal from hydroxyl, surrounding 3I Atlas. This detection provided the first concrete proof that the comet was actively outgassing, releasing water vapor into the cold vacuum of space. Without Swift, this discovery would likely have remained hidden. That finding, now, allows astronomers to measure the comet's activity level and compare it directly to comets from our own system. This comparison is invaluable. It tells us whether the fundamental processes of comet formation are universal, or whether they vary from star system to star. The water mystery deepens. An unexpected location. The presence of water was surprising, but the location of that water was even more puzzling. When the hydroxyl signal was detected, 3I Atlas was nearly 3 times as far from the Sun as Earth. At that distance, sunlight is generally too weak to turn surface ice directly into gas by normal sublimation. To picture this, imagine trying to melt ice cubes with a candle from across a large room. The heat would not be strong enough. Yet, 3I Atlas was releasing water vapor at an astonishing rate, approximately 88 pounds, 40 kilograms, per second. Researchers compared that flow to a fire hose, running at full blast, continuously spraying water into space. A different mechanism at work. This led scientists to propose a different mechanism. Rather than ice sublimating directly from the comet's main nucleus, the nucleus may be ejecting a spray of tiny, ice-coated dust grains. Why would that matter? Because of surface area. Smaller particles have a much larger surface area relative to their volume. Break an ice cube into tiny pieces, and those pieces will warm and evaporate faster than the whole cube. Similarly, faint sunlight at that distance can efficiently heat these grains, turning their icy coatings into gas, and creating a vast cloud of water vapor, an extended source, around the comet. This type of behavior has been observed only in a few distant comets, and suggests that 3I Atlas has a complex internal structure. It is not a uniform ball of ice, but rather a layered and sophisticated object with varying compositions. What this discovery means. A message from another world. Dennis Bodewitz, a professor of physics at Auburn University, put it simply. When we detect water, or even its faint ultraviolet echo, OH, from an interstellar comet, we are reading a note from another planetary system. It tells us that the ingredients for life's chemistry are not unique to our own. That statement carries weight. Water is not merely important for comets, it is essential for life as we know it. Finding water on an object from another star system tells us that the building blocks of life exist throughout the galaxy. wherever this comet came from. Its home system shares the same basic chemistry that makes life possible here on Earth. Additional observations from Mars. The story grew more exciting in early October, when 3I Atlas passed near Mars. Two spacecraft orbiting the red planet turned their instruments toward the comet and managed to catch a glimpse. The European Space Agency's ExoMars Trace Gas Orbiter captured images of a fuzzy white. The comet's icy nucleus, shrouded in a coma that stretched over 1,000 kilometers. Although the nucleus itself was too distant to resolve, the observation confirmed that the comet was still active. This observation was incredibly challenging. The comet appeared roughly 100,000 times fainter than the Martian surface, the usual subject of these orbiters. Imagine trying to photograph a candle flame from many miles away, while standing beside a brightly lit billboard. Yet, the team succeeded, and provided another valuable piece of the puzzle. Looking to the future. What we have learned. The study of 3I Atlas reinforces an important lesson. Every interstellar object is unique, each with its own story to tell. We cannot generalize from a small sample. Oumuamua was dry. Borisov was rich in carbon monoxide. Atlas releases water at unexpected distances. What will the next visitor reveal? For now, scientists can only wait and watch. These differences are more than curiosities. They give us crucial information about how different star systems form and evolve. Just as studying people from different cultures teaches us about human diversity, studying comets from different systems teaches us about cosmic diversity. Each visitor is a scientific treasure trove. The broader implications. This detection connects to a profound question. Are we alone? While the discovery does not answer that question, it tells us something vital. The chemistry necessary for life exists beyond our solar system. The basic ingredients are out there, scattered among the stars. It also shows that interstellar objects are not mere curiosities. They are messengers, carrying information about distant worlds we cannot yet reach. As our detection methods improve, we will likely find more of these travelers, each one teaching us something new about the galaxy we call home. A testament to human ingenuity. The discovery of water in 3I Atlas is also a tribute to human creativity. Scientists could not see water directly, so they looked for its fingerprint. They could not observe ultraviolet light from the ground, so they used a space telescope. Faced with a mystery about distant water, they developed a new theory, involving ice-coated dust grains. At every step, researchers found creative solutions to difficult problems. This is the essence of scientific exploration, observing what seems impossible, asking why it happens, and slowly, patiently, building new understanding. Conclusion. Comet 3I Atlas is more than a frozen ball of ice and rock, passing through our solar system. It is a cosmic messenger from a distant star system, carrying clues about how planets and comets form across the galaxy. The detection of water vapor, confirmed through the ultraviolet signature of hydroxyl gas, marks a significant milestone in the study of interstellar objects. This alien comet has shown us that the ingredients for life exist beyond our own system. It has reminded us that interstellar visitors continue to surprise us, challenging our assumptions about planetary development. And it has shown that with the right tools and determination, we can read messages from worlds we may never visit. As we continue to study 3I Atlas during its brief passage through our neighborhood, and as we watch for future interstellar visitors, we do something profound. We learn to read the story written in the stars, one cosmic traveler at a time. Each visitor rewrites what we thought we knew, expanding our understanding of the universe and of our place within it. The next time you look up at the night sky, remember, somewhere out there, another interstellar wanderer may be heading our way, ready to tell its own unique story. And, thanks to dedicated scientists and sophisticated instruments, like NASA's Swift Observatory, we will be ready to listen.